All right, this is page 3 of lesson 4.2 on probability. And let's go and talk about events. This is multiple events. So right here, multiple. So what if you want to know the probability of two events happening? Instead of talking about a single event, we're going to talk about two events that are happening. So when we talk about multiple events, so we have P of event A, and then P of event B. So this means probability of event A and probability of event B. We want to know the probability of both of those. When that happens, you multiply probabilities. So you find the probability of them individually, and then you multiply. So let's go back to this bag here. We still have 8 total. Now here, what's the probability of a red and then pulling a blue? Well, the probability of a red, P of R, well, we'll just put P of red, that is going to be 4 out of 8, right? Or 1/2. The probability of a blue, well, this says with replacement. So when we pull this red, we put it back into the bag. And so we still have 8 total marbles. So the probability of a blue then is 3 out of 8. So that hasn't changed. And to find the probability of red, then blue, is going to be 1/2 the probability of the red times 3/8. And we multiply tops, that gives you 3, multiply bottoms, 16. So 3/16 is going to be that probability. Now once again, we could change it to a decimal or percent, but for this I'm just going to leave it as is. Now this is with what we call replacement. In other words, we pull the marble, we see that it's red, and we put it back into the bag. But what if we didn't put it back in the bag? What if we pulled it out? How would that change the probability? So without replacement, P of red is still the same, right? There are 8 marbles. What's chance of pulling out a red? Well, that's 4 out of 8, which is 1/2. But now the probability of blue changes because there aren't 8 marbles in the bag. We pulled a red one out and we didn't put it back. Now the probability of blue is there's still 3 possible outcomes, but there are only 7 marbles. So this becomes 3/7. And so the probability of red, then blue, is different if you don't replace. So it's now 1/2 times 3/7. And when we multiply, you get 3/14. Now, I think in this case, changing them into decimals is going to be advantageous because, like, which one's a better probability? And so let's change them to decimals. First, I guess go ahead and you guess. Which one do you think has a higher probability of being pulled? Does replacing it give you a higher probability, or not replacing the marble give you a higher probability of pulling a red and then a blue? Well, let's go ahead and change them into decimals, and we can compare them that way. This makes it a lot easier. So this is 0.1875, which is 18.75%. Where if I do 3/14, that's actually 0.214. I'm going to round it to 3, which is 21.43%. So not pulling the marble back actually created a higher probability of getting 1 red and then 1 blue. All right, let's talk about this part. This is how do I tell? This is fair versus unfair events. And so when we talk about something that is fair, sometimes you'll hear the term, what is a fair die? Like, is it a fair die? And what would be the opposite of that? It would be a loaded die. And so a fair die has an equal chance of getting any of the numbers that are on there. So if this is a fair die, I should have an equal chance of rolling a 1 or a 2 or a 3 or 4 or 5 or 6. It should be 1/6. But if a die is loaded, meaning they'll put a weight in it so that it has a tendency for a certain bottom side to land on to stay on the bottom. And so, maybe you put the weight here so that you get 6 more often than you don't. So they would weight the die, and my understanding now that the casinos are pretty sophisticated, and they even have sensors that can tell whether a die is loaded or not. Because it used to be, in the old gangster movies, they'd roll the die and it was loaded die, and so they would do it like a switch. They'd have the casino's die, and then they'd find a way to switch it out for their loaded dice. So how to tell if something is fair? All outcomes have an equal theoretical probability. Now, an easy way to show this, the difference between like fair and something that's unfair. If I had a spinner, so there's a circle divided into 4 sections, 1, 2, 3, 4, and it has a spinner like this arrow, right? And you spin it and the spinner spins around. The probability of getting a 1 or 2 or 3 or 4 should be 1/4, should be 25%, right? But what if I made it like this? This would clearly be unfair, right? 1 has a greater probability than any of the others, and 2 has the least probability of any of them. So this would be something that would be unfair. So just to kind of give a visual of that. All right, so go ahead and take a look at these 4 problems here. Go ahead and solve them. Pause the video, solve them, do the best you can, and then let's review them together and see how you did. All right, so looking at the first one here, the probability of rolling a 4, well, there's 1 4 on a 6-sided dice, and I apologize, typically we're just using 6-sided dice for this. So it's 1 out of 6, because there's only 1 4 on here, right? Should only be 1 4 out of 6. Now, what's probability of rolling greater than a 4? Well, there's a 5 and a 6, so 5 and 6 are 2 outcomes that are greater than 4. So we can say a 5 or, sorry, I wrote 4 and I said 5. A 5 or a 6, that meets both criteria of being greater than 4. So there are 2 outcomes out of 6, which would give you a probability of 1/3 or 33%, 33.3 repeating. For this one, the probability of rolling a 5 and then rolling a 5. Well, the probability of rolling a 5 is 1/6. Because there's only one favorable outcome. There's only 1 5. But this is multiple events. So it's the probability of a 5 times the probability of a 5. So this is 1/6 times 1/6. You multiply across, 1 out of 36. Now the one thing that's kind of nice about this is we can see this on the table. So if we flip back to the previous page, where's my previous page? Hold on one sec. There we go. Here's the table that we did with 2 dice, right? How many of these show you a 5 and a 5? This one right here, right? One die is a 5, the other die is a 5. There's only 1 outcome out of these 36 that actually have 2 5s on them. And so that is consistent, 1 out of 36. And then for our last one here, what's probability of rolling a 2 or rolling a 4? Here you have 2 favorable outcomes. This is not 2 events. This is 1 event, and you're considering 2 outcomes for it. So this is 2 out of 6 or 1/3 again. So when you have an and, then here this is talking about 2 events. The or is talking about the same event, but considering two different outcomes. All right, that ends page 3. Please continue to page 4.